chapter 2, lesson 5, exercise 7. This is about GitHub Actions. So the goal of this exercise is to take the Python Flask application code provided in the course materials and add a GitHub action to it, so it builds a Docker image and pushes it to Docker Hub. Additional requirements is the image name and image tag, and also that is supposed to be, the image supposed to be built for two CPU architectures. I have some notes about this. So first, maybe to mention that there are some typos in the course, and one is that the leading slash should not be here, and the link here provided in the course exercise description is not right. The code can be found in other subdirectory. So this setup assumes that I clone the course repository, I cd to the examples directory, made Vagrant app. It assumes that Vagrant is functional here on my laptop. So here I'm in this window on the OpenSUSE Vagrant box. And additional requirements are, in order to perform this exercise, we need Docker Hub and we need also GitHub. So on Docker Hub, after we sign up for the account, also we need to create a token, and this token needs to be stored in a secret place somewhere. Then on GitHub, after joining, we create a repository, Python Hello World, that will be hosting our solution. So here in this window here, I'm on GitHub and can create a repository. It will be new repository. It will be private. There's no need to make this public. And then we add also a license, because it's important for any project that we are making on GitHub to have a license. Otherwise, people have no rights to make any modifications to our project. They can only clone it, or actually fork it, and that's all. So this is probably not what we want. So this private repository will be created, and it gives some instructions. But if I go here, I can see that the license, it's already populated, so I can also clone this repository directly. We will see it in a moment. But what I have to do, I actually have to take this Docker Hub token and set it as a GitHub repository secret. So Docker username and Docker token will go there. And since this is a personal token, I will do it off screen. So the secrets for this particular GitHub repository have been set, and we can go back to the instructions. So now what I will do, the goal of this exercise is to use to configure a GitHub action. However, while doing this, we can encounter many errors, and it's a bit long. It takes a long time to push changes to GitHub and wait for the action to perform, and whether it works or whether it fails. And we have to check logs online. That takes time. So there is a project called Act, which can run GitHub actions locally. But in order to do that, it requires Docker. So I will install Docker inside of the OpenSUSE Vagrant box. So I will just proceed with this. So these are the steps that can be found also in this official OpenSUSE Docker installation instructions. So it's still taking some time, so let's just wait with that. So here what happens, basically a Docker daemon and client is installed, and then the Vagrant user, this $sign user that corresponds to Vagrant in a Vagrant box, is added to the Docker group on the system, and then that makes the Vagrant user allowed to use Docker without sudo. So that's a bit slow, but let's just see how it goes. Okay, now it's there. Then I will add Vagrant to the Docker group, and since I modified the group of the user, I have to exit from this session, make another session, and can now confirm that the Vagrant user is assigned to the Docker group, and also to Vagrant. That's done by default. Now another thing that we need is actually Git, because we'll be operating with Git on the command line. And another thing now is to in order to interact with the remote GitHub repository, we need some kind of authentication mechanism, and in this case I'll be using SSH keys. So there are instructions how to do that, also like official instructions from GitHub. But I will just execute those commands, and this will create the private key, which is very secret. We should not show it to anyone. This will be the private one, which does not end with pub, and there will be also at the same time generated the public key, which ends with pub, and this public key we have to upload to GitHub, and this is on the account level. I will just show it in a moment, but let's just create this key, and it's password protected, so that's a good thing. We can also do it without password protection, but I will do it with a password. So the keeper has been generated, and now I can cut the contents of the public key. So I will just take the whole thing here, the string, and what I want to do, I want to now on the account level add this SSH key, and I will call it exercise 7. So that will make it possible for me to interact with this with actually my whole GitHub account from the command line. But in order not to be required for typing the password every time I do some operations against GitHub, I will start something called SSH agent, and this SSH agent will be remembering the password as long as it is running. So I will add the private key here to the SSH agent, and now it's asking for the password, but that will happen only once. So another thing is what is important, that sometimes GitHub may block SSH connections, and this kind of shows that if you try to git push, then this will be hanging. And in order to fix this, SSH can be used over HTTPS, because HTTPS it's less likely to be blocked by GitHub. So this is a special configuration file for SSH, and it tells that, okay, I mean, if you use GitHub, then actually SSH against GitHub, just use this port, and this will work. So the next thing is to install this tool that I mentioned, this act tool that allows me to execute GitHub actions locally. So I will fetch the binary, I will fetch the checksum, then I will extract this specific binary for this architecture here, x86-64, into its own file. So I can show that this is just checksum for this specific archive. Then we can check the checksum, and it's good. So the binary can be extracted from the archive and put also in this typical path on Linux, but also needs to be made executable. And from now, this act should be available. and also we see that it has relatively recent version, actually the latest. So now to the actual solution of the exercise. So let me first switch to the Vagrant folder, which is shared between the Vagrant box and the laptop host. I will clone the repository here of the course, and I will also clone the repository I created. But since we are in the exercise folder, there is already a folder called Python Hello World, so I will clone it at Python Hello World 1, and we can see that I was able to clone the repository from GitHub. Now the thing is that if I would like to, okay, let's just first enter this repository and see what's inside. So there's only this license here, but what we want is actually to copy. Let me modify this a bit. So I will say that we that will be in this step here. We just enter there because this is what we did, and we will take this from level up. But there's one additional configuration step, and this is we have to provide Git with configuration of our email and username, and I will do it again off screen. So the email and the username have been set up, so that's basically the email you registered with the GitHub and also your GitHub username, so that shows kind of identifies you in your commits. So we are already in this directory. I entered here, so what we can do, we can copy the contents provided to us. Of course that's not the right thing to do because there is some missing things, so that's the right thing to do. Let me just correct this. There's no need to recursive copy, and then here there was some problem with the space, I don't know why, but anyway, here here in the git status, these are the new files that we are adding. The license already was there, so we are adding new files, and these are the original files that were provided in the course materials. So what I will do, I will just make a commit and we'll say that the materials have been added, and I can also just push this to the remote GitHub repository. And after I do that, I go back to this repository, maybe make this larger a bit. Now we have two commits, and the first commit is the license, and then the other one is those initial source code that we were given from the course. So the next thing to do is actually to implement the GitHub action. So first thing is to, yeah, there's a bit of a description here, but basically the GitHub actions require that there is a YAML file. It can be any name, not necessarily main, some YAML file inside of the GitHub workflows directory. So that's one thing, but as I mentioned, when working with the GitHub actions, it takes a long time to push those commits, so it's much faster to use this act tool for local testing. And once we know that local testing is good, then we can push the final commit to the remote GitHub repository. So but there's one thing that this workflow, GitHub action workflow, will use a secret. We'll use this Docker Hub username, Docker Hub token. So act also has a way to provide secrets, and the easiest way is just to write them in a file. So basically I will also just do it out off screen in a moment, but I want to mention something very important, that we should, I mean, the safest way is not to store this file even in the current directory, I mean in this directory, since by mistake we may commit this, and this contains our Docker Hub token, and that would be something that may allow others to use our Docker Hub account. So we need to create this file, and also the safest thing to do is also to make this file, this my secrets, even if it's one level up, but by mistake it may be that it somehow ends up in the current directory of the GitHub repository, the local Git repository, and then just to prevent this from being committed to GitHub or included as inside of a Docker image when it's built, then those two commands can be executed. So I will just execute this and execute also the other one, and then I will just go offline and write my Docker Hub username and token inside of this my secrets file, which is will be located one directory up. So this has been done, and now kind of we can move to the main part of the exercise, which is to figure out how to write this workflow YAML file, this one here. So I will say that probably I would say that the best way is to actually do it like this and say that we are creating this file because this step is missing. So we first create a directory, and then we have to write something inside of it. Maybe that's not the right indentation. No, I think it's okay. So, and in order to do this, we have to search for some GitHub action that allows us to build and push Docker image. So I will search for this GitHub action, and then we will say Docker push. Okay, so we will use this one, I would say. And here we need to find some kind of example how to use it. So there is an example, but this one is a bit more does not include everything we want. So path context, maybe this one may be better. So what I will do, since we don't have it yet, but I will do GitHub workflows, and I will use an editor to just create this main YAML GitHub action. So what this thing is doing, so it's called CI. This could be any name. It works on pushes on branches, and this is the master branch, and uses the latest Ubuntu runner. So this is 20.04 Ubuntu, which is the latest stable version of Ubuntu. Then checks out the let me just show it here. It checks out this because it will be part of this repository. Here there will be this .github workflows main file located here, and that's how GitHub will know to execute this as an action. And inside of this execution there will be checkout of this repository, and there is QEMU just to build those two different CPU architectures. And there's some setup, there's logging to Docker Hub with the secrets that have been set up already. And then there's this main part that builds and pushes. So context dot is okay, this is the local directory, and that's okay because Docker file is here and all the source is here, but that's the Docker file that matters here. This is incorrect, because this should be our GitHub, our Docker Hub repository. So this will be then written like this, and this was called Python hello world. And there's another thing missing, so let me just go back to this platforms. So we need to take this parameter here and include it there. Actually, maybe the best way is just to look for platforms here. Okay, so that it's actually the documentation is saying that the QEMU can be used to build on more platforms, but there's like not much documentation here. There's this, just this, and this tells there's some example maybe. Yeah, so there are some examples how to do that. So we just use the parameter called platforms, found here in this documentation of this action. So this is something that could be, we could try to execute. And in order to execute this, I will not do that yet. Instead, maybe actually I will move this. Yeah, there are some steps that are not in order. I would say here, test action, packed. I mean, this actually has been written here, so maybe that's not really necessary. Yeah, maybe it's actually fine. But I will first just try to execute act without pointing to the secret file, just to see how this works. So once more, we have the following. Okay, the tree is not there. I would like to have it. I think this is probably what will work. Yeah. So let me just also go to git and tree. I'll just add it here. So we are now at this step where I would like to show the structure of this repository. So it looks like this. Okay, and then there's of course GitHub action here. So what act will do, it will, okay, I ran already act before, but it will ask what kind of image of act we want, and there will be like one very large, which is 20 gigabytes, and then there's the medium size. So the medium size, it's 500 megabytes, so this one we could choose. And here actually it was very fast. It already told us that okay, username and password is required, log into Docker Hub, and that makes sense because this command does not say anything about the secret. So now if I execute this command here, but pointing to the secret file, then it actually should be at least start building the image. So let's see what if this happens. So for now, what is happening still not right, so I have to debug a bit and I will be back. So I believe the problem is simply because this is not the right path to the file, to the secrets file, because I stored apparently somewhere else. So I have to refer to the full path of this file, and it's actually in home vagrant, not in the one level up. My secrets. Let's try like this. So here actually you can see that QEMU is listing what kind of CPU architecture is supporting. So now it seems that the logging has passed, and some kind of building, first pulling of the image, Python image is happening, but I will stop this. So let me just try to stop this process, because it seems that it's working, and I will just directly commit to GitHub, commit this change to GitHub. Okay, it's terminated. So let's see what's the state we have. Okay, so we have docker ignore file, we have git ignore file, and we have also this GitHub action that we configured in the main YAML, GitHub workflows main YAML, this one. So I will just add all those files and commit them. Actually, this probably is in the instructions, so let's just see. Yeah, okay, I just did something different, but it's fine like this. So I would say that we can just try directly to add this GitHub action and then git push. And once this push is executed, we are expecting to see an action to be started, but it's not. So, and then there is a reason for this, and the reason for this is here. I mean, this branch is called main, but when I took this code from the documentation of Docker build and push action, it has master. So what I will do, I will just edit this GitHub workflows, and I will change it to main. This is actually the result of the recent changes from master to main, and that of course causes some problems like this in documentation. It will be causing probably problems for still some time. So now we are expecting to see an action to be triggered. And is it triggered or not? It is. So we can see now that the action is starting, and it will contain all those steps that we listed. So we log in to Docker Hub, pull the base image. You can actually see it here in the Docker file. So basically we pull this image, copy the contents of this directory. This is also why it's very important not to have at least git ignore of the secret file, and copying like this is dangerous because there can always be something sensitive in this local git repository. But anyway, after we execute the pip to install the requirements and kind of finish building of the image, and now it's still doing it, and it's also because it's building both architectures. There is ARM and there's AMD. But now it says that it's done. So since it says that it's done, then we should see, there's this green check mark here, then we should see it actually on Docker Hub. And there will be something quite surprising, because there's also a funny thing that there are already several pulls. Yeah. So the last thing to do will be to actually check whether this is working. So I would say this image, Docker image, is working. Hello world. So in one terminal, I would just pull this image. Yes, there's a mistake here. No, that was actually good. So that will be in one terminal inside of the Vagrant box. And if I do docker ps, I can see that of course there are those act containers that were used previously, but this is the main application. It's called test here and uses the image from the Docker Hub. So what I can do, I can just try to curl it, and the problem with this is that it's permission denied, so that's probably because I need to exit and enter again the session. And there's the output hello world, so the exercise worked. So I think I will stop here. Thank you.